Structure of atom. Democritus. Democritus was a Greek philosopher who lived between 470 to 380 BC. He developed a, he developed the concept of atom, Greek for invisible. His mentor Leucippus originally came up with the atomic theory, but it was then adopted by Democritus. Democritus had many remarkable insights for his time. He understood that the Milky Way was a large collection of stars, and also true the space was limitless. Democritus' atomic theory stated that matter consists of invisible particles called atom and a void empty space. He stated that atoms are indestructible and unchangeable. Also, that they are homogeneous, meaning they have no internal structure. His atomic model was solid and stated all atoms different size, shape, position, and arrangement with a void exists between them. Democritus knew that if you took a stone and cut it in half, each half had the same properties as the original stone. He reasoned that if you continue to cut the stone into smaller pieces, at the same point you would reach a pieces so tiny that it could no longer be divided. This this was Democritus' atomic model. It is simple around sphere with no electrons, proton, or neutron. Democritus created the first atomic model. Democritus called this infinitesimally small pieces of matter atoms, which means invisible. The atomic theory started that the universe is composed of two elements, the atoms and the void is in which they exist and move. According to Democritus, atoms were minuscule quantities of matter. Democritus hypothesized that atom cannot be destroyed. Differ in size, shape, and temperature are always moving and are invisible. He believed that there are infinite number of atoms. This hypothesis was created in 465 before Christ. All matter consists of invisible particles called atoms. Atoms are indestructible. Atoms are solid but invisible. Atoms are homogeneous. Atoms differ in size, shape, mass, position, and arrangement.
Structure of Atom by John Dalton. John Dalton, he was born on September 6, 1766, was an English chemistry physicist and meteorologist. He is the best known for his pioneering for work in the development of modern atomic theory and his research into colorblindness, sometimes referred to as Daltonism, in his own honor. Dalton's model of atom, which is proposed that all matter is composed of very small things, which is called atoms. It is not completely new concept as the ancient Greeks, notably Democritus, had proposed that all matter is composed of small, invisible, cannot be divided objects. John Dalton atomic model. Elements are made of extremely small particles called atoms. Atoms of a given element are identical in size, mass, and other properties. Atoms cannot be subdivided, created, or destroyed. Atoms are different elements combined in simple whole number ratio to form chemical compounds. In chemical reactions, atoms are combined, separated, or rearranged. John Dalton theory state all elements are called atoms. Atoms of given elements are alike. Atoms of different elements are different. Chemical changes take place when atoms link up with or separate from one another. Atoms are not created or destroyed by chemical change. John Dalton's atomic theory, which is composed of oxygen, hydrogen, water, and then hydrogen peroxide, and then oxygen is composed 32 gram, hydrogen is 4 grams, and then water is composed 36 grams. Oxygen and oxygen, hydrogen plus water is equals to 32 gram plus 4 grams is equals to 36, which is equal naman siya. Oxygen is 32 grams and then hydrogen is 2 grams and then hydrogen peroxide is 34 grams, which is 32 grams plus 2 grams equals to 34 grams. It is equals, and then it's called law of conservation of mass. Kapag yung oxygen and hydrogen naman is 32 grams and then 2 grams equals 16. It's called law of multiple.
J.J. Thomson. Biography. Joseph John Thomson, who was always called J.J. Thomson, was born in Cheetham Hill, England, near in Manchester in 1856. His father was a bookseller who planned for Thomson to be an engineer. Thomson was sent to by this time at Owens College at the age of 14 in 1876. He married Rose Paget and they had one son and one daughter. Published 13 books and more than 200 newspapers in his lifetime. And died August 30, 1940 at age of 83. Electrons. J.J. Thomson discovered electrons in 1897. Electrons. J.J. Thomson discovered electrons in 1897. Thomson in 1897 was the first to suggest that one of the fundamental units was more than 1,000 times smaller than an atom, suggesting that the subatomic particle now known as the electron. Thomson discovered this through his exploration on the properties of cathode rays. How did J.J. Thomson discover the electron? He was studying electric charges at Cavendish Laboratory in Cambridge, England. He used a cathode ray tube to discover the electron. Cathode ray tubes are vacuum tubes that contain two electrodes, one on each side. One of the electrodes fires electrons at the other when voltage is added to the system. When Thomson fired up the tube, he saw a beam of light between the two electrodes. To figure out what they were, he applied a magnetic field and found out that the beam moved toward a positive charge and away from a negative charge. From this, Thomson determined that this little cathode ray rays had negative charge. Cathode rays He used cathode rays tube to discover the existence of electrons. It consists of vacuum sealed to keep. It is negatively charged conductor. Also consists anode that is positively charged. The cathode ray tube consists of several elements starting with the tube that vacuum sealed to keep air out of it. One side of the inside of the tube there's a cathode and anode. The cathode is a negatively charged conductor and the anode is a positively charged conductor. Electrons which have a negative charge flow of the cathode and are attracted towards the anode. A small hole in the anode allows some electrons to pass through it, creating a beam of electrons. On the opposite side of the tube is that electrons. This allowed J.J. Thomson to see where the electron beam was hitting. Of course, before his experiment, we didn't know electron existed, so no one was calling it an electron beam. Instead, what flowed off the cathode toward the anode were called cathode rays. Hence, the name cathode ray tube. J.J. Thomson Atomic Theory. He was the first to offer evidence from scientific experimentation showing that the atom was not the basic and indivisible unit of matter. He discovered the electron by experimenting with the crux or cathode ray tube. He also studied positively charged particles in neon gas. He realized that the accepted model of an atom did not account for negatively and positively charged particles. J.J. Thomson Plum Pudding Model. Plum pudding model proposed in 1904. He likened his model of atom to plum pudding. The negative electrons represents the resins. The dough contained the positive charge. It was rejected later after Ernest Rutherford's gold-foiled experiment.
Structure of Atom by Ernest Rutherford, a physicist scientist. Ernest Rutherford is a student of J.J. Thomson, a New Zealand native working at the University of Manchester at early 1990s. Spent most of academic career researching aspects of radioactivity, and in 1908 won the Nobel Prize for his discovery. Related to radioactivity, it was after this when he begins developing his model of atom. In 1908, Rutherford conducted his famous gold foil experiment. In this experiment, he discovered his atom model. Rutherford designed a very famous experiment that proved that the atom is mostly empty space. He bombarded a very thin piece of gold leaf with alpha particles. Although some alpha particles were reflected, most passed through, proving that a dense nucleus was at the center of the atom, but not much else. With this experiment, he discovered his atom model with the following features: that exists the positively charged centered in an atom called the nucleus, that nearly all the mass of an atom is concentrated in the nucleus. Electrons revolve around the nucleus in well-defined orbits. The size of the nucleus is very small compared to the atom. Rutherford model of the atom is a classic model of the atom. The Rutherford model shows that an atom is mostly empty space with electrons orbiting a fixed positively charged nucleus in set predictable.
Structure of Atom by Niels Bohr. Niels Henrik David Bohr was born in Copenhagen on October 7, 1885. He is a professor of physiology at Copenhagen University, best known for his substantial contributions to quantum theory.
winning research on the structure of atom. Bohr became interested in physics at a young age. He studied the subject throughout his undergraduate and earned a doctorate in physics. Under Rutherford's tutelage, Bohr began studying the properties of atoms. He came across Max Planck's early quantum theory, which described energy as tiny particles or quanta. Atomic model. Bohr was the first to discover that electrons travel in separate orbits around the nucleus, and the number of electrons in the outer orbit determines the properties of an element. Bohr's greatest contribution to modern physics was the atomic model. The Bohr model shows the atom as a small, positively charged nucleus surrounded by orbiting electrons. Niels Bohr model of the atom is very small, positively charged nucleus which contains proton and neutron, surrounded by negatively charged electrons. Niels Bohr atomic model was improved model from earlier cubic model, the plum pudding model, the saturation model of Rutherford model. Niels Bohr applies quantum Rutherford's atomic structure and assuming that the electrons travel in stationary orbits defined by their angular momentum. Niels Bohr atomic model is more similar to the solar system are orbiting around the sun, except that let's discuss about the atom. Where is nucleus? It is a central part of an atom, composed of protons and neutrons, contains most of an atom's mass. Proton is a positively charged particle found within an atomic nucleus. Neutron is an uncharged particle found within an atomic nucleus. Electrons, negatively charged particle located in shells that surround an atom's nucleus. When electrons orbiting a nucleus, they will emit the electromagnetic